In this presentation, we will discuss the concept of waiting line and queuing theory based on our observation conducted at Kopiology Machang, located at number 7, Bangunan Baru Depan, Bandar Machang, Kelantan. For this study, Kopiology operates from 10 AM to 10 PM and the observation was conducted between 2 PM and 5 PM, which represents a relatively busy period. During this time, the cafe operates with one server handling customer orders. This observation allows us to examine how customer arrivals and service rates affect waiting time and system performance, and how queuing theory can be applied to evaluate the efficiency of the service system at Kopiology.
First, we go through the arrival characteristic of the queuing system at Kopiology. First, the size of the calling population follows an infinite population model, which means there is no fixed limit to the number of customers who may arrive at Kopiology during operating hours. Customers can come at any time throughout the day. Next, the pattern arrivals is random, where customers arrive independently of one another. The arrival rate is represented by n customers per hour, depending on the time and demand. Lastly, the behavior of arrivals shows that the customers are patient customers. This means they are willing to wait in line and will remain in the queue until they receive their orders without leaving the system.
For this slide, I will discuss the waiting line characteristic at the cafe. First, let's look at the queue length. The queue length is unlimited, which means customers are allowed to line up as long as need. There is no fixed limit on the number of customers waiting. Next is the queue discipline. The cafe uses first in, first out, or FIFO. This means customers are served based on the order they arrive.
Next, the third characteristic of a queuing system is the service facility. First, the number of channels at Kopiology is a single channel system because all customer orders are handled by one service counter where customers are served sequentially by the same service facility. Second, the number of phases is a single phase system because customers only need to go through one stage of service, which is placing an order and receiving their drinks from the same service counter. Third, the number of waiting lines at Kopiology is a single waiting line because all customers form one queue and are served on a first-come, first-served basis.
This slide shows the data collected on customer arrival, service time and waiting time at the cafe. From the table, we can see that customers arrive at different times throughout the observation period. Each customer goes through several stages, which are order start, order end, and order receive. This stage represents the service time taken by staff to prepare and serve the order. The waiting time after place an order is mostly between 4 to 5 minutes. Most customers only wait around 4 minutes and sometimes it becomes 5 minutes when the cafe is a bit busy. Next, calculation part. We start with the arrival rate. The number of arrivals per time period is 11 customers. The value of M is 1 because there is only one server handling the orders. Next, we calculate the average number of customers served per time period. The total waiting time after order is 48 minutes. So, the average time per customer is 48 divided by 11, which is approximately 4.36 minutes per customer. To convert this into hourly rate, it takes 30.76 and approximately 40 customers. In conclusion, this system can serve around 40 customers per hour with only one server.
Next, I will continue explaining the calculations for the waiting line system at Kopiology. First, we will find the average number of customers in the system. denoted as L, is calculated using the formula L equal to lambda over mu minus lambda, and substituting the values, we will get L equal to 11 over 14 minus 11, which gives 3.67 customers, meaning that on average, there are 3.67 or approximately 4 customers are either waiting or being served in the system. Next is the average number of customers in the queue. LQ is calculated using the formula LQ equal to lambda square over mu multiplied with mu minus lambda, and by substituting the values, we will get LQ equal to 11 square over 14 multiplied with 14 minus 11, which result in 2.88 customers waiting in the queue on average. Next is the average waiting time in the system. W is calculated using the formula W equal to 1 over mu minus lambda, and by substituting the values, we will get W equal to 1 over 14 minus 11, which we will get 0.33 hours or approximately 20 minutes. And lastly, we will calculate the average waiting time in the queue. WQ is calculated using the formula WQ is equal to lambda over mu multiplied with mu minus lambda, and after substitution, the result is 0.26 hours or approximately 16 minutes, representing the average time customers wait before being served.
Next, we look at the system utilization and probabilities. First, we calculate the probability that the server is busy, which is denoted by rho. By substitute the values, we get rho equals to 11 divided 40, which is approximately 0.79. This means that the server is busy about 79% of the time. Next, we calculate the probability that there are 0 customers in the system denoted by P0. Substitute the values, give P0, and the last answer is 0.21. So there is a 21% chance the system is empty, meaning no customer are being served or waiting.
This table shows the queuing analysis for Kopiology using an MM1 model, which means there is one server, random customer arrivals, and exponential service time. The arrival rate lambda is 11 customers per hour, while the service rate mu is 14 customers per hour, indicating that the server is capable of handling customer demand. The average server utilization is 0.79, which means the server is busy 79% of the time, showing a relatively high workload but still manageable. On average, there are 2.88 customers waiting in the queue, LQ, and 3.67 customers in the system, L, including those being served. The average waiting time in the queue, WQ, is 0.26 hours, which is approximately 15.7 minutes, while the average time spent in the system, W, is 0.23 hours, or about 20 minutes. Overall, this indicates that the system operates efficiently, although customers may still experience a moderate waiting time during busy periods.
Next, I will explain the waiting line characteristic observed at Kopiology Machang. The first characteristic is queue length. In this system, the queue length is considered unlimited, which means that there is no fixed maximum number of customers allowed to wait in line. Any arriving customer can join the queue even during busy periods. This situation is common in cafes where customers are usually willing to wait rather than leave immediately. The second characteristic is queue discipline, which follows the first in, first out or FIFO rule. Under this system, Customers are served strictly according to the order of their arrival. The first customer who enters the queue will be the first one to receive service. The FIFO discipline helps to ensure fairness and transparency in the service process. It also reduces confusion and dissatisfaction among customers because everyone understands that service is provided based on position in the queue.
Next, let's look at operating characteristics. The operating characteristics of a waiting line system are measures used to evaluate how the system performs in terms of congestion, waiting time, and service efficiency. There are 6 main operating characteristics, which are L, the average number of customers currently in the entire system; LQ, the average number of customers specifically waiting in the queue; W, the total average time a customer spends in the system from entry to exit; WQ, the average time a customer spends just waiting in the queue before service start; Rho, server utilization, or probability that the service facility is being used or busy; and lastly, P note, which is probability that zero customer in the system. By monitoring this, we can mathematically prove whether our service is fast enough. Let's look at this basic queuing system configuration. This diagram illustrates the basic queuing system configuration used in our analysis. It specifically shows a single channel, single phase system. As you can see in the diagram, the circle shape was present a customer that was arrival and enter from left, then queue in the line. There is also one service facility which is square shape. Once the service is complete, the customer exit the system as a depart. In conclusion, we have evaluated 2 main questions regarding Kopiology performance. The first one is the number of server provided adequate? The number of server provided is adequate because this cafe can handle customer demand under normal operating condition. During peak hour, servers are able to manage the queue efficiently, although waiting time may slightly increase. The second question is, are the customers happy with the waiting time? Yes, most of the customers are happy with the waiting time because the orders are prepared in efficient and waiting period is reasonable. The pleasant cafe atmosphere and friendly staff also make the waiting experience more comfortable.